What up, everybody? Welcome to another coffee hour with Paul Abernathy. Thanks for joining me on a Monday afternoon. We are live. This is not a broadcast of a recording. This is live. I got my coffee, got my cute cup. Says you had me at Wolf. And when is it a time for coffee? Anytime is a time for coffee. So welcome to tonight's coffee hour. Again, my name is Paul Abernathy, and thanks for joining me. Love having you here. We all love the code, the National Electrical Code. I owe my entire career to the National Electrical Code. So thanks for joining me. Tonight's show, we will be looking at optional calculations for dwelling units or a single family dwelling. And so that's what our topic is tonight. Hopefully you've watched a previous coffee hour where I went over the standard method and you got something out of that standard method, because it's important that you know how to do the standard method. Why? Because even though we're going to do the optional method, which always ends up in a smaller service application versus a standard, you still got to know how to do the standard, because you got to know how to do what? You got to size that neutral. Okay. So we're using the standard method for that. 220.61 is found in part 3, which is for standard. Although we do get permission in the last sentence of part 5, 220.82a, that tells us that we can determine our neutral loads based on 220.61. So we end up getting back there. We don't have to worry about that. We'll make our way back there. But we're going to do the optional method. So hopefully you get something out of this optional method tonight. And again, as I always say, make sure you have your calculator handy. Make sure you got any pens to make some notes. You never know when my math could be wrong. You know, things happen. So I need you to be those eyes and ears. And remember, you can always post in the chat if you got any questions or anything you want to chime in about that's germane to our topic. And more than happy to talk about it. All right, so this is a code, and we're going to be looking at part 4 this evening. So it's the optional feeder and service load calculation. In our case, we're going to say it's a single family dwelling. Okay. So already off the bat, I have no idea what you're talking about, Seth. We're doing the optional method, so it got nothing to do with what you're talking about. All right, so welcome to the show anyway. So we're going to do the optional method for single family dwelling. And so let's kind of get started. So what we're going to do is we're going to go over into our presentation, and we'll get started from there. All right, so in our presentation, we have some givens that we want to talk about, and these are going to be consistent with what we did when we did the standard method for this dwelling. So same dwelling, not going to reinvent the wheel here, but we're going to now do it using the optional method. So as always, we're going to look at all the things we have on the screen here. Assume water heater, clothes dryers, counter-mounted cooking units, wall-mounted ovens, everything that was given or will be given in KW, it's going to be considered equivalent to KVA, right? We like to work things into VA. So we're going to try to do all that and work all that down. So we're going to look at some dimensions here and work that. So dwelling unit, the outside dimensions, 35 by 55. Okay, so that's our dwelling dimension. We have a front porch included within these overall dimensions. So that's included in that 35 by 55. So it's a front open porch. So as we saw, we're going to take that out of the equation. That comes out of the square footage. Where do we get all those rules? That's in 212.11 when it tells us how we come up with the square footage. Next, we have small appliance brand circuits. Now, the code says that we only need to have a minimum of 2, but we know we can go above code. And if you actually do install more than 2, you have to account for them. So in this case, we're putting 4 of them in this dwelling. Next, we have the laundry brand circuit. So the code also at that point says that you have to have at least 1. Again, we're talking single family dwelling. We are not talking multi-family dwellings where there's a laundry on site. We're talking single family dwellings. So if you're just itching to comment about the allowance, save yourself some time because we're talking about single family dwellings and you only look foolish if you did so. Laundry brand circuits, it's going to be a minimum of 2. We've got, well, not a minimum of 2. We only need 1, but in our case, we got 2. Next is a water heater, 4.5 kW, which is the same as 4.5 kVA. And of course, you know, I like to work things down to the VA. So 4,500 VA. But remember, again, kW is equivalent to kVA. Dishwasher, we have a 10 ampere at 120 volt dishwasher as an appliance. We don't use that motor rating for that dishwasher. It is considered a standardized, it's an appliance, so it doesn't come in a horsepower rating. Why is that important? Because in some cases, you'll get things that will all be in horsepower rating, and you'll get some things that will be in just plain amp ratings. Typically for things like when we're looking for the largest motor and stuff like that, we're looking for actual motors, horsepower ratings, and we typically wouldn't take things like the dishwasher and things like that. But what I will tell you is that in real world, and we're talking real world here, that additional 25% for the largest motors probably not going to change your factors. The good news is when it comes to the optional method, we ain't got to worry about that when it comes to the calculation, right? We only have to worry about that when we do the neutral. But we don't have to worry about that when we're doing the ungrounded hot conductors, right? So saves us that worry. The next we've got is the, we got the trash compactor, 7.5 amperes at 120 volts. Of course, you all know, and I'm sure you all are savvy, and y'all know that we're going to have to take all of these ampere ratings and we're going to have to convert them into a VA value. And of course, we will as we move through this. I'm sure y'all already knew that. The next we have 3 attic fans, and I had a funny little comment on last video. The guy says, I don't know what he was getting. He said, the attic fan's 4.2. Well, there's 3 of them, fella. So 4.2 times 3 is 12.6. Oh, okay. Kind of wasted a comment there, didn't you? But anyway, there you go. 12.6 amperes. And it's 120 volt. There's 3 of them at 4.2 each. We have a clothes dryer in our case here, same as we did last time. It says 5.5 kW, which is equivalent to 5.5 kVA, which if we want to break it down, 5.5 times 1,000. So we're at 5,500, or you can remember the K signifies 1,000. So we're at 5,500 VA, right? Which would be equivalent to 5,500 watts. But you know me, I like the VA. We want to work at VA. Let's see here. We've got a counter mounted cooking unit. So it's got a cooktop, same as before. It's a 7 kW. And we have a wall mounted oven, which is a 6 kW. And at this point, these are nameplates, right? These are straight off the pieces of equipment. We have a electric heat. We have 3 banks that are separate heating for, it's in line with the air handler, but this is separate heating, which is 3 banks of 5 kW each. Okay, so 3 separate banks of 5 kW. And we'll look at how this kind of different ways that we might look at this so they can help you depending on what your situation is, whether or not you're dealing with a heat pump, supplemental heat, whether you're dealing with baseboard heat, or in this case, 3 separate. And we tell it to you this way so that it's very distinctively why we're saying it's 3 banks. And we'll discuss that later. But overall, it's 15 kW, which is, again, synonymous with what? Right, that's right. 15 kVA, or 15,000 VA, or 15,000 watts, although we like VA. Next, we got an air handler. Again, it's the blower motor, 3.2 amperes at 115 volts. We have air conditioner compressor at 16.6 amperes at 230 volts. And we have a condenser fan motor at 2 amperes at 115 volts. Now, the only difference here, which you might experience on an exam or somewhere, is probably in real life, is that these are probably going to be given the air handler and a condenser fan motor and that type of thing, and as well as the air conditioning compressor. It's probably going to be given to you in values of horsepower. Okay, typically that's what you run into, right? So keeping that in mind, you could see it in many different ways. In our example here, we just already simplified it for you, but you're still going to have to calculate out and get the VA, because we're going to have the overall VA for us to even be able to do these calculations, right? All right, so we've kind of laid the foundation for what we need to do. Have a little coffee. Yes, it's 8 o'clock, 8:10, still having coffee. So we're going in. You can have coffee anytime. All right. So let's get into the first thing. What do we do? Okay. And of course, we will go to the code when necessary in order to look at anything. So what do we do first? We have to go to 220.82. We're going to be in part 4. Of course, that is the optional method. And we're going to be starting in part B, which is 220.82. We'll be talking about the general lighting. Of course, part A gives us directions, but part B is where we're going to be kicking it off in order to do get all of our values and start collecting everything in order to keep this within the coffee hour. I don't know if I guess I should be able to do this in an hour. All right, so we're also going to do the exact same thing. It's still going to be giving us 3 VA per square foot, which is the same as you had with the standard method. We're going to use the outside dimensions, no differently than we did the standard method. See, we're starting off, it's just as easy, right? There's no different than we did with that standard method as we did with the previous coffee hour where I talked about the standard method. Nothing different. Obviously, also, we have that open porch of 70 feet that we have to deduct away from it. Okay, remember, that's part of those overall dimensions, and we've done it right here. We did 35 by 55. It's 1,925 square feet. But we're going to take away that 7 by 10 open porch, front porch. So that's 70 square feet. Got rid of that. So that gives us 1,855 times 3 VA per square foot. So that gives us 5,565 VA. Okay, so you're going to want to write that down. Just kind of keep that right there. Or if you got a great memory, you can remember it. If you don't have a great memory, you're getting old like me, then it pays to write this stuff down. All right, so that's our first one. Now we're going to go on to the next. All right, so let's see here. We knocked these out right here. So we're going to move on now to the small appliance branch circuit values. So the small appliance branch circuits must be included when calculating a dwelling unit per 220.52a. Each small appliance branch circuit is calculated no less than 1,500 VA. Now, we have to have at least 2. That's 210.11c1. Our dwelling just happens to have 4. So we're going to account for all 4. It's kind of something to remember. So if you're wiring a house and you do your minimum of 2, but you say, ooh, I want to add 1 more for the dining room. Ooh, I want to add 1 more for the pantry or whatnot. Guess what? You got to account for that. You got to add to it. If you're going to run another branch, small appliance branch circuit, you got to account for it. All right. All right. So we have 4 in our case here. In our single family, we have 4. So it's going to be 1,500 VA each. Okay. And these loads can be included in the general lighting load and subject to demand factors provided in 220.42 if we were doing the standard method, right? We got all those rules that you'd have to follow for that method. But we're doing the optional method. Okay, so bear with me. So we're going to take that 6,000. So that's where it differs. So the important note starts to differ a little bit than the standard method. Okay, little different in how we approach this. So we want to write this down, 6,000. All right, so let's tackle that laundry. Okay, so again, the laundry part we're going to do. We have 2. And so what does it say? Well, the code says we have to have at least 1, and this is single family dwelling. So we're not even going to get into whether or not it's a multifamily dwelling. We're going to do that at another coffee hour where I get into multifamily applications, and we'll be talking about those in 220.84. So that's for a future episode. Hopefully you'll join me with your coffee and we'll be able to have that discussion. We have at least 1 laundry. In our case, we've got 2. They're 1,500 VA each. So what we're going to do is we're going to account for that. So, and again, you see here it says laundry branch circuit. I have no idea why that says SABC, but who knows. So 2 times 1,500, that is 3,000. So we add that to our equation. So currently, here's what we got going on. We have got The 5,565 VA, we have that for their general lighting, right? We got that going on. We've got the small appliance branch circuit at 6,000. We got that going on. We got the laundry at 2 of them at 1,500 each. That's 3,000 going on. Now, here's where we start to get a little different, and we'll go look at the code. But here's where we get different. Because at this stage, if we were doing this, then we would go and be able to apply some demand factors in 220.42. But we're already going to get some good benefits here by using the optional method. So we don't want to do that, right? Now, there is some caveats here for the optional method, okay? One thing you have to understand to be able to do the optional method, it has to come up with the overall, has to be 100 amperes or greater at the end of this. For you to be able to stick with this optional method, okay? If it is less than 100 amps, then you got to shift to the standard method, okay? So it tells us that right at the beginning. And the standard method, if you're not familiar with it, is part 3. We're in part 4. If you have not watched my previous coffee hour, please watch it. It's pretty good. It's not bad. I say so myself. I'm biased, of course. What can I say? All right. So now what we're going to do here, let's go look at the code and kind of get what our lay of the land here is. So here's what the code says. And so you see that A was just giving our general information. It tells us what this applies to, right? Single phase, 122 40 volt or 208 Y 120 of a 3-wire set, the feeder. Again, it's 100 amperes or greater. We get all those rules. This is what tells us that in lieu of part 3, we can use part 4, all of those rules. And it tells us to take the results of 220.82b, which we're getting ready to do, and the results of 220.82c, which we are still going to do, and then add the two together. Okay. So that's what we're doing. So ultimately, this becomes so much easier than doing the standard method. And most people are going to use the optional method, except again for the neutral. All right, so let's kind of see what we got here on the screen. Let me scroll slightly down a little bit so we can see everything we got going on. All right, so here's B. So we've already done the first part, right? We did the 3 VA, that's 220.82B1. We did the 3 VA per square foot. We got that. Notice it, again, it says all the same rules about the open porches and things like that. So we've already taken care of that with that 70 square feet. We're done with that. Number 2 tells us about the 1,500 VA for 2-hour 20 amp small appliance branch circuits. We had 4. We got it. Also reminds us in there about the laundry. We had 2 laundry circuits, but again, only required 1 per the code, but we got 2. So we're good. We've counted for that. Okay. So 220.82b, 1 and 2, we're done, believe it or not. And we wrote those numbers down. Let's move on now to the next. Let's go to start looking at the appliances. All right, so let me shift us back. All right, let me get back where I gotta be. Okay, so we took everything, and this is what our totals were, right? So 5,565, we had 6,000, we had 3,000. You add them all up, that should be 14,565. Don't take my word for it. Calculate it out to verify. But that's what should be our general lighting and receptacle load values. We sit those there for a second. We're going to do something with it, but kind of bank those numbers right now. Just write those off to the side. All right. So we've kind of covered this part, all this up here. But now we're going to start getting into these appliances. All right. So what is an appliance? It's an appliance designates utilization equipment commonly built in standardized types, washing machines, things like that, disposals, all those things, dishwashers, all those things are built in standardized types and sizes. Okay. Now, yes, they can vary, but typically they're going to have all of the pretty much the same componentry, right? Again, reminding you for the purpose of these load calculations, KW is the same as KVA. Don't need to get that confused. Okay. Now, when you're looking at the different motors, they will typically have, in the real world, they'll have a horsepower rating on it. That distinguishes that as a motor, especially if it's important for us, for example, when we're doing a standard calculation for the largest motor application. Now, in our case, the only time we're going to need that when we're doing the neutral is if our largest motor has neutral loads, right? Because we're sizing the ungrounded hot conductors right now. That's what we're doing. We're doing all that at this moment. But it's important to remind you that you could get your different things with a horsepower rating. Typically, a garbage disposer is going to have a horsepower rating. That's what you would use for that. Dishwashers are not typically appliances, just going to get a VA. Or you're going to have to compute a VA based on the amps that are written on the nameplate plus the voltage. So you'll have to calculate that out. In most cases, we'll give you that. But again, just be aware that you might have to do that. Okay, so, and again, how do you do that? Multiply voltage by amperage. Produces the volt amp. Okay. So that's just how you would do it in a normal, if you did like normal electrical math in order to come up with your VA value. All right, now, one huge difference between the standard method and the optional method is this when it comes to appliances. Are you ready? You do not get to do the 4 or more where you get to apply the 75%. Now, there's a reason for that. You're going to get one huge demand allowance here in the optional method. Huge. So you don't need that 75% demand factor for 4 or more appliances. So you're going to take the nameplate rating of all of your appliances. Now, the interesting thing here is we'll look at the code in a second, but you're going to add all these appliances. Ultimately, you're going to take the nameplate ratings again also of the cooking equipment, all of that. You just take it all. You'll see. Simple. This one's easy, right? That's why typically you don't see the optional method on exams because it is pretty easy. And on the exam, they want to at least make sure you know how to do all these little pieces in part 3, right? So that's probably why they do it. But in the real world, you're going to probably use optional method probably 99.9% of the time. Okay. All right. So you don't get that, but you have to account for all the appliances and their nameplates. But have no fear. We're gonna get some demands here. So don't worry. All right. So here's all of our appliances that we're looking at right now on the screen. And again, we just carried these over. And so what we're looking at. And so what we've got is we've got water heater. We look at that, 4.5 kW. Of course, you and I both know by now, we're savvy. We get this. We've watched other videos. We've watched many of our experts like Ryan Jackson. Ryan Jackson, welcome to the stream. Tom, welcome. And Seth and those. I see you, O. Don't think I don't see it. Look at that. Yeah, I got coffee on me. It's coffee hour. Enjoy some coffee. Of course, if it's Ryan, he's probably got some beer from a local brewery or something, you know, one of those, what do you call, microbrewery things. Probably got some of that cracking. All right, so we got a water heater, 4.5 kW. We know that we treat that the same as what? It's equivalent as what? kVA. Of course, we know we want to break all these things down into VA. That's how I like it. So 4,500 kW is the same as 4,500 VA. You know I like VA, so we're going to break it to that. We got that dishwasher. Now, remember what we talked about, the little math equation? Okay? In the math equation, we're going to take amps times the voltage, right? And that's how we're going to get VA. Trust me. Break this bad boy down into VA. Don't make it difficult for yourself. This is the optional method, man. This is, if you get these on an exam, piece of cake, brother. Real world, you're always using the optional method. I can promise you that. All right. Now, I say that with single family dwellings. And of course, the optional methods, we're going to use it when we do another coffee hour, when we're doing 3 or more in multifamily, then we'll obviously use the optional method there as well. But we'll get into that at a later date. All right, so there's the dishwasher. You see that's 1,200 VA. We had the in-sink waste disposal. Now, this is the first one here. In our case, the only one that's going to give a horsepower rating, typically the standard for a disposer. And this is a 0.5 horsepower. Of course, you all know, we don't need to rehash this. You know that if you're going to get a horsepower rating, you got to find the FLC. You find the FLC at 430.248, 249, 250, depending on what you're dealing with. Single phase, 3-phase. Well, we're single phase. So we're at 248, and that is 9.8 amperes. You could take the time and open up your code book, and I love when you open up your code book, okay? Blow that dust off of it, okay? People think I don't have it. It's right here, right here. I blew the dust off of it. Got that thing, got my stickers all over it. Okay. Holla at me, you want some stickers. All right. Now, so we've got that value. So we do 9.8 amps times 115 volts. And here's the thing. Always use the value they give you. If you're preparing for an exam, you and I both are sitting there going, well, you know, daggone well that it's 120 is the nominal. But if they give you 115, you're going to use 115. Of course, also with motor ratings, it typically corresponds with the motor rating, right? So it's 115 volts. And but you do have some nice information back there that tell you when you're back at the tables in 430.248, 249, 250. Up in the information above the table, it'll tell you that, yeah, but here's the nominal voltages, but it works with these values that are in our table. But on an exam, use that 115 volts as you see in the example. So we're doing 9.8 times 115. That's 1,127 VA. Trash compactor. 7.5 amperes is an appliance, comes in standardized sizes. I don't see them anymore, but we'll throw one in the calculation anyway. When I grew up, we had a trash compactor. The only thing it is, the trash compactor didn't work. I tried to fix it for my mom. I couldn't get that thing to work. It cost too much to replace the motor built into it and the way it interacted. So we still use it as a trash can, but it just wouldn't compact anything. What can you do? All right. So 7.5 amps times 120 volts, because that's what's given, and that gives us a 900 VA. Now we have attic fans. These attic fans, we're going to treat these as appliances. There's 3 of them. There's 4.2 amps each times 3. Okay. Now, if you're on an exam, you're taking an exam, be careful because they could give these in horsepower. If they give these in horsepower, then, you know, they could be motors, but chances are these will not be the largest motors. But again, you never know. They're usually not that very big fans. But just always be aware of that. In our equation, we're not. We're just giving to you the total amps. So 4.2 times 3, 12.6. 12.6 times 120 is 1,512 VA. Let's see what we got here. I get some beeping coming up on my screen. Sorry about that. Oh, it's just my brother back in Virginia. It's cold back in Virginia. All right. So 12.6 amps, that accounts for all 3 of them, times 120 volts, that's 1,512 VA. All right, so all these are all of our fixed appliances so far, right? So far. So this is 4,500, 1,200, 1,127, 900, and 1,512. Should be 9,239. Don't trust me. Check the math. Verify for yourself. But we're not done, okay? Now, I can show you that, because we're going to go look at the code. Don't you love that coffee exchange there where we go back and forth? So notice that it says item number 3. We did all the appliances are fastened in place, but we're not done. We got B. We got to do the ranges, wall-mounted ovens, counter-mounted cooking units. After that, we see we got clothes dryers, okay? And those that are not connected to the laundry branch circuit. So we're talking the 30 amp ones, which typically not connected to the laundry branch circuit. And of course, we have water heaters. We got a water heater, right? Now, we already counted the water heater in our appliance, so we ain't got to do it again. But again, it's important to note that water heater is separate on here, right? But we already did it. Might as well lump them together while we were at it. Okay, let's go back. All right, so here we are, and let's go on and get to the next screen, and let's start working on, oops, hit the wrong button, folks. Sorry about that. And let's start working on these other things. So let's tackle. So we're going to carry over that 9,239. I believe that was right. Yes. And we're going to carry that over because now we're going to add the other items, and we're going to add the dryer. Now, the clothes dryer is not a requirement. That's another thing I hear from people all the time. You got to add one. Now, and if you're doing an exam and they don't give you a clothes dryer, then don't assume a clothes dryer. Don't add it into something. Don't start overthinking it. That's the problem. People go down this spiral, this loop, and they start thinking, well, I've got a clothes dryer. Well, I got one. I better go and equate to it. Then you start thinking about the standard method, and you start thinking, well, wait a minute. It's got to be 5,000 or the nameplate, whichever is greater. But we're not doing the standard method here. We're doing the optional method. You take the nameplate, right? Now, just remember, if they don't give you a clothes dryer, don't assume a clothes dryer. We've got a clothes dryer in our calculation, so we've got to account for it. So here it's 5.5 kW. We know that that K stands 1,000. You could go 5.5 times 1,000, but we all know by now the K, remember 1,000. So it's 5,500 watts, or it's equivalent to VA, and that's what I like. So we'll use the VA. So the clothes dryer gets 5,500. It's a nameplate. That's the contribution that we're adding. Now, while we're at it, I'll remind you that we're going to be doing, when we're doing the standard method for the neutral, you're going to take the values, which is obviously this is even under the standard, this is higher than 5,000. We're going to be taking 70% of that value, but we're not doing the neutral yet. Because remember, the optional method said we get to go back and use 220.61, and that's the way we're going to do it. 220.61 is underneath part 3, right? So we got to get back there, but we're not there yet. This is just a reminder that it's going to be 70% of that value, okay? Now, so we carry over that 9,239 for that, and so we add the 5,500 VA to it for that dryer, and that gives us 14,739, okay? All right, just jot that down. We're gonna keep on getting it, all right? So we're at that 14,739. Now we're gonna deal with the cooking. Now here's another issue where it's dramatically different than the standard method. You don't have to worry about this 220.55. You don't have to worry about any of that. Tell you what you do. You just take the nameplate. That's it, okay? So in this case right here, we take the nameplate. We have one that is 7 and one that is 6. Now, it would probably be a good time to remind you that when we go back and we do the neutral calculation, then we still have to do it using the standard method. So that's why it's so important that you understand how to do the standard method. I don't know how many times I've heard people say, don't worry about learning the standard method. I don't know how you do this without learning the standard method. Now just think of this as the easy method, but you still got to know how to do the standard method, okay? So, because we're going to have to do that to be able to size the neutral conductor, okay? You can't use the optional method for that. All right, so in this case, we've got a 7,000 and a 6,000. Yep, you guessed it. You take that 14,739 that we got from the up to this point, and you simply add 7,000 and 6,000 to it. That should give us 27,739. Now, our cooking loads was 7,000 and 6,000, okay? But we added that to the 14,739, okay? Because that was part of the process that we're going through. So we do that and we keep on getting it. All right, so at this stage, and we already added the water heater earlier, we're done B. So we get to do something now with B. We get to apply some demand factors, right? Okay, you're wondering when we're going to apply demand factors, but here we go. So we take the 14,565, which we got earlier from the general lighting, receptacle, and laundry load applications. And then we moved on to the appliances, which is cooking and the fixed appliances and the water heater and all that, the dryer, and that was 27,739, right? So we add these two together, we have 42,304, okay? So don't trust me. Get your calculator and verify that, as I'm going to do right now. Just to be sure, 42,304. Okay, we're good to go. All right, so in our code book, what does it say we have to do? So we're going to go back to the code book and look at it so that we can see what the code book says. All right, so in our code book, right, we're going to look at this top line up here. It helps if I'm actually, mouse is on here. Okay, so here's what it's telling us. Right here, okay, it says the general calculated load shall not be less than 100% of the first 10,000 kVA plus 40% of the remainder of the following. Okay, all right. So that's our directive right there in order for us to do some work, right? All right, let's do some work. Let's go back to the calculation. All right, so back here at the calculation, here's what we've got. We've got the first 10,000, so we're going to take that 42,304. We're going to take 10 away from it, stick it to the side, And that leaves us with 32,304. We take that 32,304, we do that at 40%. And you know, as I do, anytime you see something like 40%, we always want to convert that down into the decimal point, start from the right side at 0, move 2 places to the left. Convert it from percentage to decimal points makes it so much easier. But of course, if you got a nifty dandy calculator that does it either way, it doesn't really matter. I'm just telling you. So 32,304 times 40% or 0.40 is 12,921.6. All right, that 0.6, we're going to round it to 12,922. Then guess what? Remember that 10,000 we set aside? Well, when I tell you to take that at 100%, that means we got to take that 10. So we got to add it back. So we're going to add that back. So take that 12,922, add that 10 back to it. What do you get? 22,922 VA. Guess what? B's done. Ended. You write that number down and that's your B. Remember what we said earlier? You're going to take the B and the C, you add them together. We have done B. We get to move into C. Okay. All right. Let's see here. Let's see. Willie, I'm going to boot you, bro. All right. So this would most certainly be applicable to an individual dwelling unit. You got the option to do standard or optional method to an individual dwelling unit as well, as long as it is, again, falls under this for the optional method. All right, so let's go on and see where I was actually going to go. Let's go back to the code. I can get this back to the code. All right, so we're back at the code. So now another thing before we go on, we'll remind you, you do have an item 4 here. The item 4 says the nameplate ampere or kVA rating of all permanently connected motors not included in item 3. So if you have any additional motors, right, and you need to be aware of this, especially if they're giving you an exam and they give you all these things that appear to be listed here under 3, okay? I'm just teasing you, Willie. And so at the end of the day, if you look for if you see another motor, then you guess what? We do have to count for it. It's not like you got to leave it hanging somewhere. I mean, you got to count for it. So that's what 4 is. And I like to think of 4 as that catch-all, right? It catches all those motors that are not covered, right? Or all those nameplates that are not covered. It covers things that are not captured in item 3, right? All right, so hold on here. I was teasing you, Willie, but I do have to ban this Russian dude. I don't know where they keep coming from. All right, so just as a reminder for that. Okay, so let's scroll down a little bit more. And let's now concentrate on 220.82c. I have 6 things here that I have to account for, all right? So there's 6 of them. Number 1 is dealing with, and we'll look at our example, but we got number 1 that is dealing with the nameplate ratings of the air conditioning and cooling. Okay, seems simple, right? Just take all the values for the air conditioning, everything that's associated with it, and that's at 100%. Okay. Remember, we're taking the larger, and I got 6 selections here. We don't know yet what our dwelling has. Well, we kind of do, but we haven't looked at it as far as individually yet. Next one is 100 ampere, 100% of the nameplate rating of the heat pump when the heat pump is used without any supplemental electric heat. So take the nameplate from the heat pump. If you got a heat pump, you don't have supplemental heat, boom, take it. If that's, that's the larger, go with it. The third one is 100% of the nameplate rating of the heat pump compressor and 65% of the supplemental electric heat for a central electric space heating system, if that's what you have. So if that's the case, then you would take the actual nameplate rating of the heat pump compressor, and then you take the supplemental heat at 65%. Now, important thing at the end is if the heat pump compressor is prevented or interlocked in a way that it will not operate at the same time as the supplemental heat, then I guess what? I can just take the supplemental heat application at 65%, okay? So I can do that. If I cannot guarantee that the heat pump compressor and the supplemental heat will not operate at the same time, then guess what? They are not non-coincidental in their setup. So I would have to actually take the supplemental heat at 100%, excuse me, at 65%, and I would have to take the air conditioning at 100, the heat pump compressor, I should say, at 100%. And I add the two together, okay? Not what we have, but if I did have that, just follow the rules. Let's see here. The fourth one, 65% of the nameplate rating of electric space heating if less than 4 separately controlled units. And then number 5 says 40% of the nameplate rating of electric space heating if 4 or more separately controlled units. And then number 6 says 100% of the nameplate rating of an electric thermal storage and other heating systems where the usual load is expected to be continuous at the full nameplate value. If you have one of those type of electric thermal storage units, then you're going to know what the rating is based on the nameplate of that. So depending on which one of these, now we're going to look at 2 scenarios, and the scenario that we're going to use is going to be option number 4. Assume that each one of these are separately controlled heating units, but I will also show you an example where they could be supplemental heat to, let's say, a heat pump. Again, depending on what you run into as far as your application, right? And only you're going to know it. And if it's on an exam, they're going to tell you, okay? They can't assume anything. They've got to let you know what they're dealing with. Worst case scenario, guys, is you want to go with the one that fits your best selective choice and roll with that, okay? But I'll show you as we go through it. So let me get back to the PowerPoint. And let's see how we're doing on time. I better roll here. I don't ever do an hour when it's an hour. I don't know why. I never can. Okay. So let's go on. So we write that number down. Let's move at it later. Okay, now let's take a deep breath and let's look at the loads here. All right, so what we've got here is, unlike the standard method, when you compare the optional method, you size options, you choose the largest of the 6 that we have. In this case, we're going to say the electric heat is 3 banks of 5 kW, so we're going to say that is separate heating, that type of thing. Separately controlled. Probably could have said that better, but we'll go with that. But I'll show you another method if it was not. All right, remember, it just depends on what your situation is. All right, so first thing is we want to convert all these values just so we know what we're working with, to convert them to VA. So because I've got everything. Now, I don't have to do that with the heat. You know, that's 3 banks of 5, so that's 15 kW, which is same as 15,000 watts, 15,000 VA. I don't need to do anything there with that. That's good enough. The air handler, again, we do have to convert here, 3.2 amperes times 115 volts, and I believe we do that right here, and that is 368 VA. And then we have the air conditioning compressor at 16.6 amperes at 230, and I believe that is 3,818. And then, of course, we have the condenser fan motor. That's 2 amperes times 115. I believe that's 230 VA, okay? So, and of course, again, the heat is 3 of them at 5 kW each for a total of 15, okay? So that's our heat. And then these are others that our other half for everything else. So we've got everything that we need to do the calc. All right, let's look at number 1. So option number 1 was 220.82C1. It says 100% of the nameplate rating of the air conditioning and cooling. Well, we do not have air conditioning in our values, so let's do that first. So we have to work the values up. It wasn't given to us as one lump sum. So we have the air conditioning at 3,818. We already did that. Then we add to that the condenser fan at 230. And then, of course, that air handler, which contributes to blowing that air, is 368 for a total of 4,416 VA. Okay, that's 100% of the air conditioning. So you're going to write that down because remember, that's C1. If that happens to be the larger, that's what we're going to use. So it's easier to write it down to remember it because that one is at 100%. And we already know that the other ones, we're only going to really apply one, and I'll give you an example of a second one if we applied it that way. But generally, just write that down so you know what your AC load is. I think you already know that the heat at 15 kW is going to be greater anyway, so no matter how we slice it, that's going to be the larger, but it doesn't hurt to write it down. All right, number 2, C2 was 100% of the nameplate rating of the heat pump when the heat pump is used without any supplemental heat. In some places in the country, you don't need the supplemental heat. You just use the heat pump. And if that's the case, you take the nameplate rating of the heat pump, and that's what you're going to use as your as C in this contribution. The next one is C3, and that is 100% of the nameplate rating of the heat pump compressor and 65% of the supplemental electric heat for a central electric space heating system. Again, we told you that if the heat pump compressor is prevented from operating at the same time as the supplemental heat, it does not need to be added to the supplemental heat for the total central space heating load. So basically, you just take the heat load at 65%. Okay. But in our case, we're not dealing with the heat pump. We didn't say it was a heat pump. But in case you're dealing with a heat pump that has supplemental heat, so you know how to do it. Okay. C4. That option said, the NEC says 65% of the nameplate rating of electric space heating if less than 4 separately controlled units. So we're going to assume these are separately controlled because, again, that's basically what I'm going to go with. And this is a pre-done example. So on your exam or in the real world, you're going to have clarity whether or not these are, for example, baseboard heat is separately controlled or whatnot. In our case, we're going to assume that these are 3 separate banks. But I told you I'm going to also do it as an example where it would be supplemental heat. All right, so in this case, it's 65%, so it's 15,000. I don't know what this plus or minus, whatever this is. So it's 15,000 times 65%, convert to a decimal 0.65. It pays to check your slides, folks. I'm just saying. It's late at night. I'm sleepy. So I got the coffee. So that's 9,750 VA. So far, it looks like that's a winner. So I can get rid of what I remembered for the AC because, again, it looks like I got a winner here. I don't know what this is right here. All right. So the next one was C5. Now, this one is if we had 4 or more separately controlled units for electric space heating, which we did not have. We have 3. So we're not going to use C5. But if we did, then you could take those at 40% of their nameplate rating and compare that to all the other options that are available. And typically, the only other options you're going to be comparing this to at that point would be the AC. This would be your heat, so that's what you'd be comparing it to. All right. Another thing that's different from this versus a standard is it's funny that in the standard, you know, if the heat versus AC in the 2020 code, if the heat actually, or if the AC was larger than the heat, okay, then you would already be taking that air conditioning unit at 125%, and that might be your largest motor. We don't have that worry here in the optional method, okay? So you don't compare heat versus AC, and if the heat beats the AC, but the AC has the largest motor, then you recalculated AC, the air conditioning compressor at 125%, plus some of the other things like the fan motor and air handler motor, and then compare them against heat again, and if the heat still wins, you keep the heat. We don't have any of that to worry about. Kind of weird. I don't even know why we do that for the standard method, to be honest with you, when we don't do anything like that here in the optional method. But, you know, those crazy code panel people, I don't know. Anyway, so that's what we've got. Okay, so this one doesn't apply to us, so we'll just keep on going. And then, of course, this one here is with the electric thermal storage. Again, we would take the full nameplate value for that. So you keep it at 100% of the nameplate value. Clearly, if you're doing one with this and you have one of these electric thermal storage units, then you'll know, just take the nameplate value from it, and that's what you're going to add for your contribution, and obviously compare that to your AC or that type of thing. And so whichever's larger is the one you're going to go with. All right, so theoretically now at this point, we've kind of covered all of these pieces. So we've kind of looked at them. So now we're going to start throwing things together. So now it's crunch time. We took the 22,922 from all of our B calculations. Remember, you wrote this down. And then we took our value from the C, which we determined was the 5 kWs for 15 kW, but we were able to apply 65%. So that was 9,750 in our example. Remember, in yours, it may be different depending on what type of heat you're dealing with. And ours, we went with that, and it's 9,750. So 22,922 VA. plus the 9,750 is 32,672. Divide that by 240. That gives us 136.13 amperes. We dropped the 1.3 based on 220.5B. So we just have 136 amps. Okay. All right. Now let's give you a what if. I like to do what ifs. Here's a what if scenario, right? Here's a what if. The what if is you're saying to yourself, you know what, Paul, I think that is a heat pump, and I think that it does have supplemental heat. Okay. I'm game. So if we do that, here's what we're doing. We're looking at 100% of the nameplate rating of the heat pump compressor and 65% of the supplemental electric heat for the central electric space heating system. Again, so in this case, so we argue it would be 15,000 times 65% equals 9,750. If we assume the heat pump compressor and the supplemental are interlocked and can't be on at the same time. If we cannot guarantee that, then again, it would be the value from the air conditioning compressor, okay? Or in this case, we'll say it was because we're just using a hypothetical here. If it was the heat pump compressor, I'm just throwing a hypothetical for you. And if that was the value, then we would take that, 100% of that, plus the actual value from the 65% of the heat, okay? Now, of course, I just did this real quickly, but it would be the heat pump value that's posted on the actual nameplate of the heat pump at 100%, right? Nameplate, right? But kind of give you an idea how that would equate. So we're assuming that the heat pump nameplate, again, making some assumptions here, says 3,818 VA or whatever the calculation come out to. Then it would be 13,568. Well, the big difference here, right? Let's kind of show you how this can make a difference. So this is what we had when we did it our way. We used the 5 kW heat strips and separately controlled, and we did it that way. That gave us 136 amperes, okay? So this hypothetical gives us 13,568. If we were to do that using that, it would be 22,922 plus 13,807, right? And actually, that's not correct. Hold on. Bear with me. I guess, let me see how do I, oops, wait a minute. I'm going to fix this bad boy on the fly. Hold on. I'm not sure. There we go. Hold on, folks. I'm going to fix this thing on the fly because obviously it is not correct. Hold on. Hold on. I like doing it on the fly, but how come I can't see my mouse? Hold on here. Let me do this. 568. And let's add the math. 22,922 plus 13,568 equals 36,490. So let's go on and do this on the fly. I don't know if y'all can still see that, but bear with me. Okay. So that would be that. So 36,490. Not going to change much. Divided by 240. Hold on. Bear with me. Is 152.04. Nope. Not changing anything in our math, but I like to get it right. This is an older slide. So there we go. So let's save that. And let's go right here. And let's bring us back to where we need to be. There we go. All right. There we go. Look at that. Boom, bada bing, bada bang. Okay. So we had this. So let's always check our math. So 22,922 plus 13,568, if that's what we had. That's 36,490. And let's verify 13,568 real quick, because I might have done all that for nothing. Yeah, no, 13,568. So that's what we got. All right. I think you get the point. Anyway, so here we're at 36. So we take that divided by 240, 152.04. We get to drop the 0.04 again because of the rules in 220.5B. So we drop, and I don't know why that says 0.3, obviously because I changed it, right? And so anyway, the big difference, the big takeaway here, right, is if you go look at the code, and we will, the big takeaway here is if we go to, let's see here, let me jump back up real quick, and we go to 240.6a. Let's do it together. Right here. If we go here, then again, so it was 152, right? So it's over 150, so we would terminate, we could put it on a 175 amp rated device. So that's big difference from our 136 based on the heat that we used, the 3 units, because that one was 136, so we would put that on a 150. So that's a difference. That can make a difference. So you got to be careful which one you select, because that's a difference between me being on a 150 amp breaker versus a 175, right? Okay. Just kind of to show you how that could take place. All right, back to the PowerPoint. Okay. So that was our hypothetical, you know, if we ran that, but we're going to go with ours. So we did what we did earlier. It was 136. So we went to 240.6a, and you can see here it doesn't correspond. So we went with the 150. So now that is our service rating. Okay. Our service rating based on the overcurrent device is going to be a 150 amp rated device, right? Okay. So we now know that our calculation for the optional method was 136 amps based on what we chose. Being very aware that depending on the different heats that you might be dealing with, it could put you into a different breaker altogether, right? And it's going to affect everything, because once we have a different breaker, then it could affect our minimum conductor sizing, right? All right, so there you go. We're at 150. Now, here's the next step. People ask me, now, when do I apply 310.12? The answer to that question is, if you're on an exam or in the real world, you always will apply 310.12 as long as it's applicable, right? So the service rating, in our case, doing a service, is rated 100 to 400 amperes. Of course, to use the optional method, it'd have to be over 100 anyway, right? So we have 100 to 400 amps. It's a single phase, 122/40, so we're good there. No any problems with that. So what does it tell us in 310.12a? Which, if you're not in the 2020, it's 310.15b7.1, because we're talking about a service here, okay? And if you are looking at that, it basically will say that we can apply the 83% rule to that. Now, they put the table back in there. In 2017, it was back in the form of Annex D. By putting the table back in it, I guess it's one of the things by popular demand. Everybody wanted it. I didn't see the point, because, again, you can only use that table if no conditions of use take place. It means you don't have more than 3 current carrying conductors. Your temperature is 30 degrees Celsius, 86 degrees Fahrenheit. If any of those variables change, then you can't use that little table. You're going to have to use 310.16. You're going to have to apply adjustment and corrections accordingly. And at the end of the day, it's still got to be conductors that can't be less than 83% if you want to utilize 310.12. Okay? Now, can you size them full size without using 310.12? Absolutely. That's totally up to you. If you want to do that, I work for a company that sells wire and cables. So if you want to make everything 1,000 kc mils and you can make it work out for you, you go for that. Okay. Make sure it's copper. I'm just saying, but you don't have to. Okay. So if you're preparing for an exam, more often than not, most of the exams that I've worked on is going to be pushing you to know that you can utilize 310.12. Okay. All right. So 83% rule here. So the maximum service feeder rating permitted when used in 310.12 can't be over 400 amps, not an issue with ours. So in our case, since we determined that the size of the breaker or the service rating based on the breaker is 150 amps, 83% of that. So you simply take 150, okay, 150 times 0.83, and that gives you 124.5, okay, or 125, or you could go, well, because it's a 0.5, we're rounding it to 125. So 124.5 becomes 125, okay? So what does that mean? That means I got to hunt for a conductor that's good for 125 amperes. Now I'm going to be in a 75 degrees C, because again, we are over 100 amps. So 110.14C. So we're typically, now what I didn't tell you and what you might get on exams is they might tell you that it's THHN, THWN-2 and all that type of thing. But always be familiar with the small conductor rules. Be familiar with the conductor sizing and termination rules. Be familiar with overcurrent protection device rules, all those different things. But for us, we're focused on the fact that we are over 100 amps, so we're going to be in a 75-degree column, and we need to find a conductor that's good for what? At least 83% of the service rating, which is 125 amperes. So if we go and look, we will see that it is going to be a 1 gauge. So that 1 gauge copper is good for 130 amperes, right? Okay, so that is the minimum size conductor acceptable if all of the rules in 310.12 apply. And again, if you're in the 2017 code, it's 310.15b7, okay? And specifically for services is B71, all right? Now, if it's aluminum you're using, same thing, 75-degree column, go to 310.16, just find a conductor that's going to be able to handle the load and minimum size as we calculated the 83% rule. And so that looks like that choice would be a 2-aught aluminum, which is 135 amperes. That works fine too. That's what your choice is. So the answer as far as the minimum size conductor would be 1 gauge copper or 2-aught aluminum. That's our sizing. And we also determined that our service rating as far as the overcurrent device is 150. So we kind of answered all those. Now, bonus question, what is the minimum size for grounding electroconductor to a water pipe ground electrode, assuming it's supplemented, right? So again, you know that's a water pipe ground, you got to supplement it, but you're not keen on that. That's already been taken care of by somebody else. We want to know what we got to run to the water pipe ground. Well, if you go to 250.66, and the reason that we're going to go to the table right away is because we could go to 250.66 A, B, or C if it was those types and it was a rod pipe or plate. If we were dealing with concrete cased electrode or ground ring, we could go there. We're not, we're a water pipe. So we're going to go to the actual table, and it's based on the size of the largest ungrounded conductor. In our case, we said it was a 1 copper, right? Okay, 1 copper. It says 1, you go over, and it says a 6 gauge, okay? So if we were doing that, it would be a 6 gauge copper conductor going to our water pipe ground under this application, okay? That's the size of our conductor. All right, let's go on. Let's think of a bonus question there for you. All right, so now we've done that. We sized everything. Now we got to pick up these neutrals. Now, with the neutral, we got to remember that we're doing everything based on the standard calculation. So this is going to mean that you remember what we did in the previous video, whereas we did the standard method. So these are the values that we're going to be keying in on for the standard, for the neutral, because all of these have a neutral component to them, right? These do not. However, the reason that your clothes dryer and cooking units and ovens are not highlighted because they do have a value that you're going to have to account for. It's just not inherently up front when we're talking about 120 volt and 115 volt loads, but it will be something you have to take into consideration, okay? So let's do that. So the first thing is simple, the same way we do it with all standard calculations. 35 times 55 is 1,925. Take away that 70. Remember the porch area, that's 1,855 times 3 VA. It's 5,565 so far, same as the standard. You've done this before. Next, you have the 4 small appliance branch circuits at 1,500 VA each. So 1,500 times 4 is 6,000 VA. You have the 2 laundry, remember, just like it shows on the screen, 1,500 VA each times 2. That's 3,000 VA. Now, again, at this point, we do get to apply the demand factors in 220.42, right? Because we're doing a standard calculation. Even though we're doing the neutral, it still applies. So we take the first 3,000 at 100%, and we take the portion from the 3,001 up to the next 120,000, or we like to say the next 117,000 over the 3,000. So we add up all those. It was 14,565. Take 3 away from that. What does that leave me? 11,565. Take that at 35% because that's what's in 220.42, the table, okay, for the dwelling. And that leaves me with a value of what? 4,048. Now, what I got to do? I got to take that 3,000 at 100%. I got to add it back. That's how we got the 7,048. So that was our general lighting under the standard method. Remember, we're calculating neutral right now. Okay. Next is take those appliances. Again, we don't have to worry about the water heater. That's 240 volt. But we have all these other appliances here that we're dealing with. And now remember, we have now shifted into part 3 again because we're doing the neutral. And remember the allowance where it says if we have what? 4 or more fixed appliances, then we can apply demand factor to those values. All right, well, what do we got? How many do we have here? So we had the dishwasher, we had the disposal, we had the trash compactor, and we had the 3 fan motors, 3 of them, right? So how many do we have overall? How many appliances? We got 1, 2, 3, 4, 5, 6 overall. So we're going to add all these values up. Remember, 10 amps times 120 is 1200 VA. The half horsepower, if you go look it up, 430.248, that was 9.8 amps. Take that times 115 volts is what? 1127. Write that down. Trash compactor, 7.5 amps times 120. It's 900 VA. Write that down. Then you have the, let's see, what do we got? The 12.6 amps, which accumulates all 3 of those attic motors. We just wrap them all together. And we do that at 120 volts because that's what they are. And that is 1,516 VA. So we're adding them all up. Don't trust me. Do the math. So that is let's see here. So that's 1,200 plus 1127 plus 900 plus 1512 equals 4,739. That's what I've got. Now, how many do we have? We have 6. So we have 4 or more, so we can apply 75%. So 220.53 says, so we'll take that 4,739, multiply that by 75%, or 0.75 if you convert it to a decimal. So let's do that, divided by, multiplied by 0.75. So 4,739 times 0.75 gives me 3,554.25. Drop the 0.25, so that gives me 3,554. Write that down. Next, we're going to deal with these clothes dryers, counter-mounted cooking units, and wall-mounted ovens. Now, since we're back over in the standard method, remember what we said? 5,000 or the nameplate, whichever's greater. Well, our dryer is 5.5. So we're going to take the 5.5. Now, remember what it says in 220.61b? We're getting to take an additional deduction here. And so what we're going to do, and the code permits us to do this, is we're going to take that 5,500 times 0.70, and that is 3,850. That's our contribution for the dryer for the neutral. Remember, it's 4 conductors, 2 hots, a neutral, and equipment ground. Okay. All right, so we write that down. Next, dealing with our cooking units here. So we have a counter-mounted cooking unit, which is a cooktop, and we have a wall-mounted oven. Okay. Now, you're going to do this the same way you would in the standard method. You're going to go to 220.55. In this case, you'll notice that both of these cooking units here fall under column B, because you have a column A, you have a column B, and you have a column C. Column C, you always apply, except where note 3 applies. So since we have cooking units that falls under other columns than C, okay, and we're still going to compare it to C, by the way, we're permitted, in lieu of using column C, we can use A or B. Now, if I have some that fall in A and some that fall in B, then I'm going to do all my values for A, and I'm going to do all my values for those that fall in B, and then I'm going to add them together, and then I'm going to compare that to C. But in this case, they both fall under B. So what I'm going to do is say, okay, what do I do with this value? All right, since they both fall under V, I'm going to go down the column in column B, and there's 2 units. So I'm going to add the 2 together, which is the 6 and the 7. That's 13, right? And I get to apply the multiplier. And the multiplier for 2 units is 65%. So I do 13 times 0.65. So let's do that. So it's 13. And I like to do the whole value, 13,000 times 0.65. And that gives me 8,450, right? So that's 8.45 kW, and we know we like to break that all the way down into VA. So that's 8,450 VA watts synonymous, okay? And now, we get to take that at 70%. So we take that value times 0.70 equals 5,915. So that is our cooking contribution. Remember, we're adding all these things up. Don't worry, we'll bring it at summary at the end. So next, we're going to be looking at the other loads that we're dealing with. And of course, the heating, we didn't have any that were 120 or 115. But we do have some air conditioning components that are. We have the air handler and we have the condenser fan motor. And so that was 3.2 amperes. We already did the math on these earlier. And 3.2 times 115, that gave us the total value. And I don't see the, yeah, right there. That's 368 VA. And then, of course, we had the 2 times 115. That was the 230. So we just add these two together. And that gives us 598 VA. So those are the contributions for those two. All right, the last thing we need to calculate is the largest motor. So in this case, we're only looking for the largest motor that has the neutral contribution, right? In this case, it was the 1/2 horsepower in-sink waste disposal, which is our largest motor. And incidentally, it was the only one that was listed with an HP rating, just so also happens to be 120 volts. So it has a neutral contribution, right? So we did that here. So we took that in-sink waste disposal. And again, that one was 1,127. And we could compare all of these if they were motors. And these attic fans could be, depending on how your equation's given to you. In ours, we did not, okay? So in this case, you would only compare one of the motors anyway, so that wouldn't be anywhere near the size of that in-sink waste disposer. So we obviously, even if we had 3 attic fans, they're probably going to be much smaller motors. They're not going to be 1/2 horsepower, probably an attic fan in a dwelling. So ultimately, we're going to be back at the in-sink waste disposal. And so again, we knew that was 9.8 amps times 115 volts. That's 1,127 VA. Okay, that also is the largest motor, and that yields the highest value for VA. And we only need one motor. Okay, so that's the one we're going to use. So we take that VA times 25% or 0.25, if you like to do like I do, break it down into the decimals. And that gives us 281.72, which is going to be 0.7. We're going to round that up to 282. So we pretty much covered everything that's covered in our neutral. So there's the 7,048. There's the fixed appliance contribution, 3,554. And again, that's when we applied the 75%. Here's the dryer, which was 5,500. We got 3,850. Here's the cooking appliances. It was 8,450 at 70%. It was 5,915. You remember that? I'm going quickly because, again, it's coffee hour, not coffee half day. Air handler motor and the condensing fan, we did those. That was 598. And we did the largest motor, which is 282. So we add all these up, 7,048. 3,554, 3,850, 5,915, 598, and 282 is 21,247. Do not trust me. Do the math yourself. And as I always tell my students in my programs, always do the math. I am a very, what do you say, ADHD or whatever it is. So, I mean, I could get on something and jump off of something and forget the math. So 21,247, so that is correct. All right. And we're going to take that, divide that by 240, and that is 88.52 or 89 amps. Okay, so due to the 0.5, we're going to round that to 89 amps. So in sizing, we do that. We had 89 amps, so we're going to go to 310.16 and find a conductor that is good for 89 amps. Right? In this case, it would be a 3-gauge copper, or if you're dealing in aluminum, it'd be a 2-gauge aluminum. It's good for 89 amps. Okay. One thing to remember is that the grounded conductor cannot be smaller than what is stated in 250.102C1 as demanded by 250.24C. So it at least has to be that size. In our case, more often than not, it's going to be larger than that minimum requirements of 250.102C1 for the grounded conductor. But just be aware of it, that you have to take that into consideration. Right. So in our case here, that's going to be the size of our a neutral conductor. Okay. All right. So let's take it back to the code. And we got another Russian. It's not like they've invaded the Ukraine yet, but they sure are invading my code time here. So, all right. Anyway, that's what we've got, folks. Those are the basic principles that you would follow. And let's see here. If I remember, it was 89 amps. So let's go real quick to the code just so we can end that up. And let's go to 310/16. And size our conductors again. Bear with me. I'll get there. Okay. So here we are right here under 75 degrees C. So 136. Let's see here. We're under our sizing here. Remember, we were doing the 83% rule. So that's how we got that value. But we were doing the neutral this time, and that was 89. So 89, that's where we got the 3 right here. Just made it and just jumped us into the 3. So 3 is good for 100, and our neutral was 89. So that's why that's a 3. But if we were choosing over here, we got to jump into a 2. And that's what we've got for the 100, good for 100. Okay, so let's go back and check our presentation again. See if that's what we've got. Yep, there's the 2, and there's the 3 in copper. And that would have been our sizes for our neutral. All right, okay. We verified all that. All right, guys, well, that's just about it. It's just that simple. Just remember, when you're doing an optional, you could have other things thrown your way. Just take your time. Work through each little piece. If you have an additional appliance, if you have an additional thing with a nameplate or additional something with a motor, and it's not covered in the B portion of 220.82, then guess what? You still have to account for it. So again, if it's a fixed appliance, you're going to account for it initially. But if it's something that would not fall in that list, it's not like you can't just say, well, I'll forget about it. You got to account for it, right? But you get such a demand value relaxation when it comes to the optional method. So it's why most people will use the optional method. It's just much easier for people to apply those rules. So at any rate, that's all we're going to talk about tonight. It was coffee hour. It's a little over. It was a coffee hour in 17, 18 minutes. I did my best. Again, remember, your heating, your options are going to be different than mine in my example. But remember, if you read it, it's not too difficult to apply those. And remember, do B, then do C, then add them together. It's just that simple. All right. Till next time, folks, stay safe. God bless. I hope you've enjoyed this coffee hour. And we will see you on the next coffee hour, where we're probably doing multifamily dwelling calculations at that point. So till next time, folks, stay safe. God bless. And thanks for joining me. You and your staples, Willie.